Okay, wanted to mention other ways to utilize this circuit. Let me just briefly go over the operation of this circuit again. On the right side here, you have the 12-volt battery down here, plus on the left, minus on the right. Your plus will come out the Zener diode here and go through this closed switch here. So you get plus on this side of this inductor and negative on this side. As you can see, the negative is here. And then, of course, you see these two switches are open. And then the next step in this circuit is these two switches that were closed will open, and this positive here will become a negative, and this negative here will become a positive. This positive flyback will go this direction out the high voltage diode, okay, because this switch is open at the time that these two switches are open. These two will also be open, and then the flyback cannot go here and run this other coil, but it can go down this way. So if you have issues charging this left side battery with the radiant energy from the right side battery, first of all, the right side battery created the radiant energy by charging this coil up and then opening the circuit right. And then the radiant will fly back into here, positive, and the negative will go this way, negative. If for whatever reason, and let's say you put a lead acid across here, okay, it'll charge that for sure, because the lead acid's across there. And then the lead acid will have to, go over 14 volts to dump down this 14-volt Zener to then charge up this other battery. So my proposed proposition here is that this battery is loading the circuit, okay, but it's going to load the bottom coil, not the top one. And this battery on the right side is going to load the top coil. So the left side battery loads the bottom coil. The right side battery loads the top coil. When the right side battery loads the top coil flies back into the left side battery. On the top here is a battery. And then right after that, the left side bank of batteries will have to load the bottom coil. Now, if you have two lead acids here, well, the one on the top is going to take the incoming pulse from the flyback, and then, right away after that, so fast, like lightning fast after that, the bottom battery is going to get loaded, or the top battery will get loaded. It depends which one has more voltage to offer. So if the battery here is going to receive the charge and then also do the loading, which I don't think it will, because it's going to receive a charge virtually at the same time it's being asked to load. So because it's not able to load at the time it's being charged, the one below it is available to be loaded at that time. So having two batteries here makes it possible for one battery to load when the other one is being charged and unavailable for loading. Okay? And keeping in mind that the left side battery up here is only being charged with flyback, and when it is being charged with flyback, the only load on the system at that time is going to be from the other battery down here, or this battery up here. But like I said, this battery will be charging at that time, so it won't be available to be loaded. But the bottom battery will. And it will load the bottom coil. Okay, this side of batteries does not load the top coil, ever. It only loads the bottom coil. The right side only loads the top coil. The top coil never dumps into the right side, it only dumps into the left side. The bottom coil never dumps into the left side, it only dumps into the right side. So, when the right side is open, and this is an open loop circuit because it's open. When the circuit opens, the um, the coil on the top, these two switches open, and there's your open loop circuit right there. And it flies out this diode during that open circuit moment. And keeping in mind, these two are also open. All four of these transistors are open at the same time. Only one pair closes at a time. So it's an open loop circuit. It's basically the Bedini circuit times two. The Bedini circuit is an open loop circuit. Um, and so if you have trouble uh, getting the bottom battery to load when the top battery is being charged, and it shouldn't be a problem because at the same nanosecond or millisecond that the top battery is being charged, the same rail plus and minus here is being asked for a load. Because when these two switches open, after they're open, and these are also open, but then these two will open, and then when these two are done opening, then these two will close right away after that. And then it'll create a load with this inductor onto this battery bank. So that's how fast the load shows up after before it's asked to be. That's how fast the load shows up after it's been charged. So this top battery gets charged, and then right away these two switches close and load the circuit. And at that time, it's so fast that the top battery is kind of still charging, but the bottom battery will not be receiving a charge because the top battery is in front of it. And the Zener diode will only let 14 volts pass. So it kind of makes sure that the top battery is only one charging. And then that kind of makes sure that the bottom battery is available to be loaded at that time. And since it's connected into the circuit when a load is being asked for, it's available to be loaded. So I don't foresee any problem here because two batteries can share the, yeah, even though they're both, this bottom battery will be loaded on and off at a high speed, but it will only be charged trickle charge 14 volts like the constant current charge through here, which makes it so every time that this bottom battery is not receiving a load, it's already receiving a constant DC signal. So as soon as it's not receiving a load, it will be available to receive a charge. So if it becomes a problem for these batteries to load and charge so quickly, there's two options to harness the flyback here. You can turn this into another inductor right here, and this side can become an inductor, and you can get rid of everything here, all these capacitors and everything. Just put an inductor right here, and now what you're going to have is four inductors. The top two will be uh, field charged with direct pulsed DC um, from forward energy, your battery. And these two inductors will be run with reverse flyback voltage. And you can easily take these four inductors and put them around four magnets around a wheel and essentially have a, if not 100% efficiency motor. Like Bedini said, it's better to capture the radiant with electrolyte batteries. And he's right. But you can also capture it with an inductor and use it right away to spin a wheel. So I'm not sure how efficient the inductor is at capturing the Radiant. I don't know. I couldn't say for sure if it's better than a lead acid battery. So that's why I prefer to test this out before I pass judgment on it because I've never actually finished building this yet. The circuit that I built that did work and had no shorts on it, and it was successfully running, pulsing the two inductors, was with two transistors, not four. And I believe I was switching the positive and not the negative. So that would be this switch and this switch, or the only two switches I had before. This switch wasn't here, and neither was this rail. These two switches weren't there before. And the circuit operating without these two switches was operating without any shorts. Because what was happening without these two switches is the flyback from the bottom coil, it would go out this diode here. And since they're, let me get this right here. It would go out this diode here and to the side of the inductor and I'm sorry, I was switching the negative. No, the positive, right. Sorry, the negative. These switches, the positive rail switches weren't there before. This wasn't here, and and this was not here. It was just this switch and this switch. So what happens was, if you don't have this switch here or this switch here, and it's just a line connection, the flyback will go up here and hit this coil here, and then the negative flyback will go up here. No, sorry. Yeah, it'll go up here, and I think it was going here, right here, you know. So basically, the circuit was uh, each coil would be forward charged, and when it flew back, it would go into the other coil, back and forth. The flyback was bouncing between the two coils when I only had two transistors here. But anyway, I just wanted to mention that there are other ways to harness the flyback on this rail here. You can just put an inductor here, an inductor here. You can throw out everything down here, throw it out, and put an inductor here. And it will basically pulse off the flyback. And you'll be able to use it to spin a magnet on a wheel. But until I'm done testing this circuit out with two batteries here, I'm going to put a lead acid here. I've already got one lead acid here. I'm going to keep these diodes there and keep these Zeners here, 14 volt down into here and 12 volts out. It's kind of like a voltage regulator. So it only leaves 2 volts to, it's balancing out 2 volts between the two battery banks here using this 14 volt Zener and this 12 volt. So until I do this circuit and test it out, I won't really know if a lead acid battery can load and then charge after it's loading. And keeping in mind, these batteries are technically not loading and charging at the same time. They're loading on the off cycle and charging on the on cycle. If I only had one battery here, I would say that the flyback would hit it the same time it was being loaded. And that wouldn't give it any time to provide a load efficiently. But adding capacitors here kind of eliminates that, because the flyback will fill the capacitors in, and the bottom battery won't be receiving any load. The capacitors up here will. And at the time that these capacitors are being filled up, this same circuit is demanding a load. And if you have a second battery down here, it will provide that load. So first I'm going to try it with just the capacitors. And if I don't have the results I'm looking for, I'm just going to add a lead acid battery here and then finalize it like that, see what happens then. And if I don't get results then, I'm going to just put an inductor here and drive a wheel with it because there's no way to lose with that one. You're going to have four inductors. Two are receiving forward pulses and the other two receiving reverse flyback pulses. And you have four magnets on a wheel and you pulse it and you have a high efficiency motor. All right, sorry for rambling on there. I'll end the stream briefly and hopefully that makes some sense and we can get the conversation going on about this and get other people's to this is an open source circuit and open for improvements as well and modifications. This is not a circuit that's complete. It's an experiment. So it's well, you're all welcome to replicate and feedback your results. Thanks again. Mike Does over and out.